almost the same thing. What's going on, you guys? Welcome to another awesome video where I'll be showing you how you can use Solidworks and 3D printing to create something awesome like this. Now this is pretty much like a simple planetary gear system, but what's really interesting about this is the way it's been designed. Basically, the shape of the gears is what's very important in this, in that the gears aren't just straight linear patterns around, they're kind of curved. And what that means is that if you were to CNC or manufacture any of these gears, you could never assemble this. Now, what is the point of this kind of thing? This pretty much shows that 3D printing can be used as a tool to create new and interesting shapes, designs that could not be previously done through other manufacturing techniques. A very good example is with injection molding. You need to worry about consistent wall thicknesses as well as overhangs. With 3D printing, you don't need to worry about that at all. You can have varied wall thicknesses and you don't need to worry about it. 3D printing just allows you to create new and unique shapes and will help develop new technologies and new products. And this is a perfect example of that. This could be, example, a bearing that costs a fraction of the price to manufacture, doesn't need to be assembled, and it just comes off a printer bed working. So, back to this little planetary gear, or what I call the impossible bearing, because it's impossible to manufacture in other ways. Let's get into how I made this awesome planetary gear, or impossible bearing. So we jump into Solidworks. I start off by creating a single tooth on the center gear. I then pattern this around it and create the first gear. I then pattern that upwards to create one of the outer bearings and pattern it for a third time to create a single tooth of the outer wall. I then create a circular array of all of this stuff and create the basic wall around, and that will get you your bearing shape, the gear set that you're creating. I then use the twist and flex feature in SolidWorks to create the flex that I wanted. I then kind of brought it down to shape, mirrored it over each other, and joined it all together. So fairly simple in the end. I gave it enough tolerance so that I knew when it would finish it will just crack off and work immediately, so that none of the edges are touching. Saved it as an STL and went off printing. This is printing in a Madahackers Grey Pro PLA on an Ultimaker 2. Very simple print. Once it was complete, used some tools to remove it, and as you can see, with a bit of gentle force, the gears loosen up and it's ready to be used. Just like that. As you can see, it's a very simple design, very easy to print, and pops off the bed and starts moving immediately. Saves a lot of time in manufacturing in terms. There's no assembly cost, there's no assembly time. It's just boop, on the bed, in the box, out the door. And this is a perfect example of where 3D printing could be taken in the future. I really hope you guys enjoyed this video. Hope you learned a lot from it. If you have any questions, please leave them down in the comment section down below and I'll answer them to the best of my ability. And we'll see you guys in the next one.